the basic statistics, the meaning of mean and standard deviation. The meaning of the ABCD of statistics, the mean and standard deviation. And then we will also talk about specification limit, control limit, and then sigma level, right? So statistics for 6 sigma, specification limit and control limit. What is 3 sigma process and a 6 sigma process? What is the meaning of sigma? What is the meaning of sigma level? And then benefits to the organization, right? This is how the flow will be. And now you have a slide where car is parked in a parking area. Imagine you have a parking area and you have 3 different cars. One car which is very big, bigger than the parking area. Another car almost similar to the size of the parking area. Another car which is half the size of the parking area. Now tell me, which car will be more convenient for your regular use? Will you go for a bigger car or the medium size car or the smaller car?
Last one.
Last one. This thinking is, 6 sigma. This is what Takuchi also said. Takuchi said variation is loss. If you allow the car size to increase, some point of time it will go to the extent of damaging your car. Instead of that, go for the minimum variation. Your process will also, like the car is having a size, your process will also have a size. If you allow the process size to increase, at some point of time, the process will start causing damages. All of you, do you understand the logic? The first one, the car is bigger than the parking area. Every time you park the car, there will be a damage cost. Second scenario, car is almost similar to the parking area. At times, you will park the car safely when you are careful enough. Suppose while parking the car, you get a phone call from your girlfriend. What will happen to your car? Your car is now under risk, right? Suppose if you have a smaller car, you are parking the car, you are getting a call from your friend, you will still manage the call as well as park the car safely. Am I right?
Yes.
Right. Same situations will happen in business also. Something can go wrong. You can't expect your people, always stay focused. They will have girlfriend and boyfriend and everything. So there will be some disturbances. Your supplier can bring variation. What I'm trying to say is there are such certain factors which are uncontrollable in nature. These uncontrollable factors will tend to disturb your process. Like your girlfriend calling you during office hour. There will be some uncontrollable factor will coming and playing in your process. Even if the uncontrollable factor plays, your process will still tolerate and produce products meeting the customer specification. Such a process is called 6 sigma process. Do you understand?
Yes.
Yes, sir.
You have a mindset which is stable enough to attend the call of your girlfriend as well as park the car safely in the parking area. That is the capability you have got. Such a process is called capable process. In fact, the process is called doubly capable. Even if a disturbance comes, it won't fail. Supplier is suddenly, sent material slightly with some variation in the quality. Then also, you have a mechanism to take care of the issue that can happen in the customer end. An operator, suddenly has took leave, and now your process is capable of managing it. All these possibilities are there. Am I correct or not? Your machine, your equipments can undergo wear and tear. As a result, problems can happen. But can you avoid wear and tear of the machine? If you use it, it will undergo wear and tear, isn't it? So certain factors are uncontrollable, but you will design a process in a way that the uncontrollable factors are controlled through the controllable factors. Do you get my point? The uncontrollable factors are controlled through the controllable factors. Your girlfriend has made a call. You can't control her, but you can still control the car. Am I correct or not?
Yes.
This is how you should design the process. When you design a process in such a manner, your process will now be called doubly capable. Even if something wrong is, going to happen, your process will carefully avoid it and still produce the output as per the expectation. This is called the Six Sigma. And now look at the parking area. It has got certain walls. Am I right? Parking area has got a wall here. Parking area has got a wall here. If your car touches this wall, your car will get damaged. Similarly, if your car touches this wall, your car will get damaged. These extreme points are called specification limit. As far as the driving process is concerned, this is the borderline. When you are driving a car with all your family member, you know where the road ends. Am I correct or not? On the left side, the edge of the road will be there. Right side also, the edge of the road will be there. Will you go and try to touch the edge of the road?
No.
Same thing you should do in business also. Customer will tell you what is the borderline. They are called specification limit. I need a plate of thickness 100 mm. I need a plate of thickness 100 mm. Do you think customer will give you some tolerance?
No.
Because 100 mm, exactly 100 mm, who can produce? Because in this world, uncontrollable factors will always be there. So customer will give a tolerance. Am I correct or not with my statement?
Yes.
If the customer is very strict, he will give a very, very narrower tolerance. If the customer is very liberal, he might give a wider tolerance. Let us consider a wider tolerance. 100 plus or minus 0.5. Now tell me, what is your upper limit? 100 plus or minus 0.5. I am okay to accept thickness 100 plus or minus 0.5. Now what is the upper limit?
100.5 is the upper limit and 99.5 is the lower limit.
Beautiful. So 100.5 is the upper specification limit. The right side wall in your parking area is 100.5. The left side wall in your parking area is 99.5. Now you always ensure that you drive the car between 99.5 and 100.5. If you go and touch 99.5, you are damaging your car. If you touch 100.5, you are damaging your car. Don't do that. The best place to drive the car is exactly 100. The center of the parking area. Am I right?
Right.
So where are you trying to park the car? Statistics can answer. Central tendency can tell you. If you are parking the car at the center, that will appear in the mean. That will appear in the median. That will appear in the mode. Do you understand how the central tendency is helping us? If I collect some data, calculate the central tendency, either mean, median or mode, that will tell you where are you trying to park the car. Right? All right. So we understood. And now one more example. Now imagine you are the pilot. You have to land the aircraft in a runway. You may be, flying the Boeing or Airbus. Now tell me, this is the runway. Now where is the upper spec? Can you see the upper spec here?
It is right.
Right side.
Right side.
What is this part? This line?
The load.
And the center of the specification is the targeted, is the customer targeted value. 99.5, 100.5. Obviously, the center, the average of it will be the target value, which means all your customers will be happy if you land the aircraft around the center line. There are 300 people sitting in your aircraft. See here, most of the time you are landing here. You know why? Because customer, the passengers expect that. And you are also doing it. That means, you are a very good pilot. Am I right? Yes. Suppose if you try to land here, 10 times you will land perfectly. 11th time you will land somewhere here. Am I right or not? So your intention should be to land at the center. If your intention itself is here, finally you will land somewhere here. You will see every passenger, lying here. We should never try to, deviate from the center. The deviation from the center is called variation. Can you see some deviation here in all the landing points?
Yes.
Is that all the landing points are exactly on the center?
No.
No. You wanted to land in the center, but you are not able to. You know why? There are certain factors which are uncontrollable, isn't it?
Yes.
When you are flying, there will be wind velocity and many things which you can't control everything. That is the reason why the variation you are seeing here in the data points. So you are landing like this. You are again landing. You are again landing. You are again landing. When I collect sufficient number of points, I am now able to see a bell-shaped pattern in my data. This will happen in all the data and you can make it happen. This will happen in all the data and you can make it happen. It all depends on sample size. It all depends on sampling technique. Do you understand? Sample size if it is sufficient. Sampling technique if it is correct. All data will definitely exhibit this. That is the single reason why you can solve any problem in the world using the concept of normal distribution. Though there are several distribution available, you can still solve all the problem using normal distribution if you know the technique of making your data follow a bell-shaped pattern, which is called normal distribution, which is also known as Gaussian distribution, because Friedrich Gauss, the German mathematician, he is the one who introduced this concept. You can call it bell-shaped curve, you can call it Gaussian curve, you can call it normal distribution. All are same. Now, what is this point? The customer preferred point. Am I right?
Center.
The target. What is so? Whether your driving is in line with the customer preferred point or not. Customer target is this. But as a pilot, where do you target your flight? This is very important question. Am I correct or not? All the passenger want to see you landing around the center line. But as a pilot, what are you doing? I want to know. How do I know? I will calculate average using all your landing points. Do you understand? Do you get my point?
Yes.
Yes, sir.
If the average appears to be on the target, you are a fantastic pilot. Customer requirement is understood by you. Customer requirement is understood by you. Customer wanted 100 mm thickness. You understood it. That is why it is reflecting in your average. Do you understand how statistics is helping you?
Yes.
You want to hit a mango on the tree. You are throwing 100 stones. Not all 100 stones are hitting the mango, but all the stones are going close to the mango. Now you are now you have got the skill to hit the mango, right? So certain stones might miss the mango by 1 feet. Certain stones may miss the mango by 2 feet. Certain stones might miss the mango by 3 feet. But if your stone is going beyond 3 feet, you don't know how to throw the stone. Am I correct? 1 feet, 2 feet, 3 feet, I can tolerate. But when I want you to hit the mango and you are throwing the stones, somewhere completely different, 3 feet away from the target, you don't know how to throw. You are never going to hit the mango. That is the idea. So any deviation from the target is unpreferred. Now average tells you what is your target. Customer target is here, your target is here. This creates a healthy scenario in all business. All of you, do you agree?
Yes, sir.
Now, what is this point? The stone which you have thrown is 3 feet away from the mango. The one of your worst performance. The flight has landed far away from the center. Am I correct here? The worst landing executed by the pilot, you could see here. Similarly, the worst landing on the left side. But the worst itself is a safe landing. Am I correct here?
Yes.
The worst landing made by the pilot itself is a safe landing.
Within the limit.
Yes. What is this? Specification limit. What is this? Lower specification limit. This is target. This is upper spec. This is lower spec. I am going to assign a name to your extreme performance, worst performance. This is called upper control limit. This is called lower control limit. The worst output you can expect from your process is happening at upper control limit. All of you, do you understand?
Yes, sir.
The worst output you can expect on the left side is happening at lower control limit. Any process will have these control limit. Whether you are throwing a stone to hit the mango, or you are landing the aircraft, or you are trying to produce a plate, metal plate of 100 mm thickness, control limits will be there. Do you agree with me?
Yes, sir.
If the control limits are inside the specification limit, you are keeping your customers safe. All the time, your customer satisfaction is ensured if the control limit is obtained inside the specification limit. Am I correct with my statement? This is
Yes.
called process capability. This is called process capability. If you could ensure the control limits fall inside the specification limit, the process is considered capable. Otherwise, there will be failures. There will be crash landings. There will be rejections. There will be customer dissatisfaction. Hope the point is very clear to all of you.
Yes.
So customer target will reflect, are you hitting the customer target or not? How do you answer this question? By looking at the average. Am I correct?
Yes.
Expectation is average should be equal to the target. And variation is unpreferred. Any business, nobody would like to miss the mango. Nobody would like to land the aircraft out of the runway. Nobody would like to produce a rejected item. Then all these people will hate variation. Am I right? Then all these people will hate variation. Everybody would like to throw the stone on the mango. Am I correct?
Yes, sir.
Where that will appear? That will appear in the variation, measures of variation. Measures of central tendency is average. Similarly, the best measure of variation is standard deviation. We'll see that. Customer limits are called upper specification limit, lower specification limit. Who will decide on this? Customer will
Clients.
decide. Process limits. Who will decide on control limit?
Internal process.
Internal process.
Process will decide. This is something decided by your process. You design the process carefully, control limit will appear inside the spec. You design it badly, control limit will appear outside specification limit. If control limit appear outside spec, lot of stones, will go far away from the mango. Lot of flights, landing will happen outside the runway. Lot of your metal plates will get rejected, right? So make sure the control limit is inside the spec always to make your process remain capable always. All of you have played this game, shooting balloon in the beach. Now, if you really wanted to hit the target, where is your target? The center balloon, red color. If you really wanted to hit this red color balloon in the center, you should first of all be very good at holding the gun in the correct position. Am I correct?
Yes.
If you don't even know how to hold the gun, if you hold it here, will you hit the balloon?
No.
So how are you holding the gun while doing something, for your customer? That is appearing in process average. If the gun is perfectly pointing the center, your process average will also perfectly point the customer target. When you want to shoot a balloon, do you want your gun to perfectly point the target? Yes or no?
Yes.
You check multiple times, isn't it? Whether your gun is pointing the target or not. That
Yes.
is what we are checking in the average. If the gun is pointing the target, it doesn't mean you have hit the target. Please understand. You are only holding the gun correctly. Am I right?
Correct.
In order to actually hit the target, you must release the bullet. So release the bullet. Now it is hitting the target. Second bullet, that is also hitting the target. Third bullet, that is also hitting the target. Every time the ball is, the bullet is hitting the target. What is the deviation here? Zero deviation. That's the time, if you calculate standard deviation, you will get zero value. Do you understand?
Yes.
But if I calculate standard deviation from your data, do you think your standard deviation will be zero?
No.
Because there will be uncontrollable factors. Sometimes you will fail to control the controllable factors. Am I right? As a result, there will be variation. Your standard deviation will gradually increase. As the standard deviation gradually increase, after some point of time, your guy, your bullet, instead of hitting this red color balloon, it will hit this red color balloon. It can sometimes hit this green color balloon also. It can sometimes hit this yellow color balloon also. If you are hitting always in the red color balloon, you know the game of business. If you are coming out and hitting all the other balloons, you do not know the game of business. Particularly, when the performance is measured using certain numbers. Hope it is clear to all of you, right? How statistics is helping us. Now, statistical formula for quality. What is written here on the left side? Can one of you read it out? What is the formula here? Statistical definition of quality. Can you
F.
read, one of you?
Quality equal to F in a close bracket X bar comma sigma.
Quality is a function of average and standard deviation. That's all. Quality is a function of average and standard deviation. If average is on the target, standard deviation is 0, your quality is world class. Am I right?
Yes.
That's all. So what's the time now? What is the time now? Is it time for your tea break?
10:50.
Oh, 10:50. We have 10 more minutes. Remind me at 11 o'clock. 11 o'clock we will break for the tea. Now it is very important for you to understand certain properties of the bell-shaped curve, because we have been talking everything based on the bell curve, isn't it? So the
Yes,
nature of bell curve you must understand. A bell curve will be symmetrical in nature. How many of you understand the statement? The bell curve will be symmetrical in nature. Draw a line at the center. Can you see the bell curve exactly dividing into two similar parts?
Yes.
This is called symmetry. If the total area is 100, I draw a line at the center. 50% you will see on the right side, 50% you will see on the left side. Am I correct?
Yes.
You could notice this in any business process also. See here, 50% of the time you landed on the right side. 50% of the time you landed on the left side. Something similar to the Pareto rule. Pareto says 80-20, but 80-20 won't happen exactly. Similarly, I am saying here 50-50. Do you think 50-50 will happen exactly? No, more or less. Sometimes it will be 51-49. Sometimes it will be 52-48. Sometimes it will be exactly 50-50. Then only the distribution is called normal. Do you understand?
Yes.
So first property is understood. If a data is perfectly normal, mean, median, mode, everything will appear at the same point. That point will be this point. Do you understand? Mean equal to, median equal to mode. What is
Central
mean? Average.
average.
What is mode? The most frequently occurring
Frequency.
data. Most frequently occurring data is mode. Then what is median? The exact observation you see at the center. If I arrange all of you in a ascending order of height, whoever standing at the center, you are now called median. Do you all understand what is median?
Yes.
Median is the point which
Central.
divides your data exactly into two halves. If the data is arranged in ascending or descending order, this mean, median, mode, everything will coincide in a perfect normal distribution. All of you understand?
Yes.
yes,
Exactly half of the value or to the left, exactly half of the value or to the right. Let us say the area, I have purchased a land for my family, right? I have purchased a land for my family. The land is in the shape of a bell curve. The land size is 1 acre. I have drawn a compound wall here at the center. I have drawn a wall at the center. Now, what will be the right side area of my land?
50%.
0.5 acre. Left side area will be 0.5. 0.5 can be called as 50%. Am I right?
Yes.
Similarly, 0.5 on the left can be called as 50%. This is what I said. The curve is
Center.
symmetrical at the center. Now what I do is, I construct one more wall here. Can you notice here?
Yes.
I construct one more wall here. Now this area of my land will be equal to 34% of 1 acre. This will be equal to 34% of 1 acre. I construct one more wall. Now this is 34 plus 13. 34 plus 13, how much it is? From center line up to this, the area is 47%. Or otherwise, this brown color area alone, 13.6%. The area between this first wall I constructed and the second wall I constructed is 13.6%. I go further and construct one more wall here. One more wall here, and you can see here, right? I constructed one more wall here. Now this area is green color. This is 2.1%. I don't want to construct wall further. You know why? My 1 acre is almost over now. Am I right or not?
Yes.
I no need to construct further wall. So don't worry about the small piece of land that you may miss. Don't worry. Do you understand?
Yes.
Because a normal distribution curve will keep on going up to infinity. You don't have to go up to there. Similarly, on the left side. Now, what do we understand after understanding this percentage? Now, when I told no, you move by certain distance. This distance should be equal to 1 sigma. What is sigma? Standard deviation. What is sigma? Standard deviation. What is the center line? Average. This average is calculated from the process data. Standard deviation also can be calculated from the process data. Now you know where to construct your walls. Now you know each and every bit of the normal distribution curve. Am I correct or not?
Yes.
This bit of the normal distribution curve is 2.1%. This bit is 13%. This bit is 34%. Everything put together is 100%. Can you see total 100%? 1 acre. Now blue color area alone. How this 68 is coming? Can one of you tell me?
We
Both right
included
and left.
both.
34.1 plus 34.1.
Beautiful. The, left and right. Left and right it gives blue color
Oh,
area. Similarly, blue plus brown area 95.45 and blue plus brown plus green area 99.73. When I come to 99.73, I realize I am at a 3 sigma distance from the center. The point which is at a 3 sigma distance from the center is actually called control limit. The point which is at a distance of 3 sigma from the center is actually called control limit. So the formula for locating the control limit is center plus 3 sigma. Center plus 3 sigma. Similarly, formula for lower control limit is center minus 3 sigma. All of you understand how to locate the control limit? What is center? Average. Average plus 3 sigma upper control limit. Average minus 3 sigma lower control limit.
Which means it covers 80% of your deviation.
Not 80%. 99.73%.
No, no.
Control limit.
Minimum.
Control limit covers 99.73%.
No, I mean to say that minimum.
99.73% of the variation is explained by control limit. 95.45% of the variation is explained by the 2 sigma limit. This point is given a name called warning limit. This is control limit. What is this?
Warning limit.
Warning limit. Warning limit will explain 95.45% of the variation in your data. What is the formula for warning limit? Can one of you tell me? Center or average plus 2 sigma.
Sigma.
This is control limit. This is warning limit. There is no special name here. This is 1 sigma. So 1 sigma means 68.27%. Plus or minus 1 sigma from the center will explain 68.27% of the problem. Plus or minus 2 sigma, the warning limit will explain 95.45% of your data. And plus or minus 3 sigma, the control limit can explain 99.73% of the variation in your data. Hope every statement made by me is understood by all of you. Am I correct? Now you have laid a proper foundation for your statistical journey. If there is a problem with the foundation, your building cannot be strong. If there is any question, please ask. Clear? All of you are thorough with this?
So
Now
why
what
it
is the time?
only-
Yeah.
Is a 94, 95? It's a standard one, or Like it can vary from different.
See, it will come close to the value if it depends on your sample size and sampling technique.
It
It
depends on the
depends on
problem.
your
Like,
sample size, sampling technique, and quality of your data.
okay.
Understand?
Understood.
So
Yes,
we
yes.
are going to learn how to optimize the sample size, how to optimize the sampling technique, how to optimize the quality of the data. Quality of the data means data should be free from error. If you ensure all these things, you will definitely see a smooth bell curve. Clear?
Okay.
So what is the
So
time now?
Sir, I
So-
have a doubt here.
One
Yes.
question.
When we compare this graph, same as you have quoted before with the landing of this plane,
Yes.
there was a upper limit and lower limit was coming there. It is like 68.27, like it is in the blue area, right? The limit of that
No.
upper
See,
1 sigma and minus 1 sigma.
No. I just I did not say 1 sigma, 2 sigma, 3 sigma. I only said it is the extreme output. This is extreme output. This is extreme output. See, please note, this is illustration purpose, nothing realistic. I have not gone to any runway and I have not captured any data. I only created for easy understanding of you, right? So this is randomly drawn and my intention is only to teach you the concept, right? I never said this is 1 sigma. I never said this is 2 sigma, but I only said this could be the extreme landing point as far as this pilot is concerned, because according to the data, it is true. Similarly, the extreme landing on the left. These extreme landing points are called control limit. That is what we are talking here also, same thing. The extreme compound wall we did here. This is upper control limit. Similarly, here it is lower control limit, which is 3 sigma away from the center. Clear? Yes, Neeraj, you want to ask something?
Yeah. So, sir, my question is, when we say 3 sigma, so and 3 sigma represent 99.73. So, is it in a sense 6 sigma, 99.73?
6 sigma will express, will explain more than
Yes.
99.73.
Sir, let me introduce, sir. Thank you
Yes.
very much. This is a very important point. When I say sigma, 3 sigma, 2 sigma, plus or minus both are included because sigma doesn't have a signature. Please note, sigma is always a dimension, signless quantity. Plus or minus sign is not there. This is like error, yeah. What is the error? You mean there will be 2% error. 2% error means on the higher side as well as on the lower side. So when we say 3 sigma, it is actually 6 sigma together, plus or minus 3 sigma. Together is 6 sigma. Okay. Thank you.
3 sigma
Sir.
on the right, 3 sigma on the left, and you are adding both, saying 6 sigma.
But you will understand more about actually what is 6 sigma process only in the end, by the end of the course only.
Yeah, I have
Right?
not explained it till.
Yeah, please, till then, don't ask me what is 6 sigma. Plus or minus is 6 sigma. Don't say that. Right?
It is kind of confusing, and that's why I asked this question.
But
because-
your thinking is correct. 3 sigma on the right, 3 sigma on the left. So the total is 6 sigma. But that is not the meaning of 6 sigma process.
Deviation has no signature. When I say deviation can be on the upper side, lower side, right hand side, left hand side. Keep this in mind.
Okay.
All right.
sure.
So is it the time for your tea? All of you?
Yes, sir.
Yes, sir.
So we
Sir,
will
once
stop.
again,
believe it.
sir, gentlemen, the person who has asked me the question, do you see that 0.1%? Do you
Yes,
see
I
that
can see.
0.1% here on the
Yes,
screen?
yes,
Yes or no?
yes,
Yes.
And do you see the 0.1% here?
yes.
On the left.
These two are the defects. This 0.1% and 0.1% is the defects if your process is 3 sigma.
See, that's what we will be explaining. Then you will be able to capture. Just park your question for a while. See, only when I place the specification limit, you come to know whether it is rejected or not. Till then, I show the specification limit. You will not be able to comment. But you know how the variation is happening. We are now only talking about the variation, right? So we stop here for the tea break. And also, what do you say? The Minitab file, installation files, and Excel template, everything is shared in the chat box. Please download all of you. And one of you Please copy paste in the WhatsApp group so that everybody is able to download, at least from one of the source. All right, we stop here for the coffee break, and after 15 minutes, we'll come again, right? We'll continue.
Okay, sir. Thank you.
All right. So we thoroughly understood the properties of normal distribution, which is going to play a big role in your Lean Six Sigma career. Whatever you had so far, that's a different time. But after your certification, you are going to see an extraordinary results happening, and the foundation for those results is going to be this particular understanding about the properties of normal distribution. You can expect anything to follow this property. You can expect anything, your blood sugar level, your blood BP level, your RBC count, your height, your weight, the product dimension, the surface finish, even the customer satisfaction score. Anything that you wanted to improve, you can expect that to follow this distribution, and you can make that to follow normal distribution. For that, you need to learn little more theory. One important theory called the central limit theorem, which I will teach you only on my Wednesday class. You come to the Wednesday class, evening class, because going deeper and deeper into the theory, might trouble some of you here. So we generally don't do that in the main session. So you volunteer and participate in the Wednesday, you get more insight. And now going to another small kind of interactive discussion. Imagine there is a group of people who are living in this village. Every single day, they have to cross the river to reach the village and then, reach the other village. And now the group leader here, he crossing the river is risky. So he don't want to risk everyone's life. So he wanted to find out the route that is best for the village people, public, to cross the river by walking, because they do not have any other device or a boat or something to cross the river. They have to walk and cross. So now he choose randomly 3 routes: route A, route B, and route C. And he walked himself, the team leader, he walked himself across route A, route B, and route C. He managed to collect some data when he was actually crossing the river through A. He was actually holding a stick or a ruler, a kind of measuring device, using which he measured the depth of the river at about 6 points. While crossing through B, he collected 5 data points. While crossing through C, he collected 7 data points. Please understand, there are infinite number of points on the route A. Am I right? Infinite number of points, but he collected only 6 data points. He followed some sampling technique, something he did, and then he collected the data. Now, after collecting the data, he calculated the depth. What is the average depth of the river? Because the risk is mainly due to the depth of the river. Am I correct?
Yes, sir.
The depth is uniform. Then the river is flat river. Then walking through the river, even kids will enjoy. Isn't it? But if there is an up and down, that is actually causing the risk. So now the average depth is found to be 4 feet in all the 3 cases. Does it mean all the 3 routes have equal amount of risk?
No.
So average can only give you a broader idea. If you also want to understand the risk involved in your broader idea, you should actually measure the risk. The risk is actually due to the deviation in the depth of the river. Am I right? The ups and downs in the river is the problem. The ups and downs is called deviation. That is what we are measuring using statistics called standard deviation. So now let us measure the deviation for route A. You need a table. How many data points he collected? 6 data points. Can you see all the 6 data points here?
Yes, sir.
And the average is calculated. Average calculation is easy. Add all the 6, divide by 6, you get average. Now you need to calculate the deviation. Deviation from the center. Center is how much? 4
feet.
Deviation from the center for the first point is 0. Deviation from the center for the second point is +1. Depth is more. Am I right? Depth is more.
Yes.
Deviation
Minus.
is -2. Depth is less. So all the depth information is captured. Everything is captured. Now total deviation is 0. Mathematically, total deviation is 0. But still risk is there. Am I right?
Yes.
Mathematically, risk is not captured in this number. It says 0 risk. No. Total deviation is,
Average it is not captured. But
because RK said no, the deviation has no signature. But here we brought minus also. That is the reason why it is becoming 0. Minus and plus cancelling and becoming 0, which is quite opposite to what we really wanted to understand. So we don't want the data to mislead us. So I want you to square the deviation. Now this is called squared deviation. 0 squared means 0. 1 squared means 1. -2 squared means 4. Now the squared deviation is written. Sum of the squared deviation is here. Sum of the squared deviation. Total, see here, sigma explained. That means sum of the squared deviation is 6. This is really throwing light on the risk involved. Am I right? Really throwing light on the risk involved. Now, what is the risk on an average? Every single step when I take in the river, how much risk I am involved? You divide this deviation, square root deviation, by a factor called n-1. N is how much? N is how much here?
Number of readings,
6.
6.
So go for n-1, you get 1.2. This 1.2 is now called variance. This 1.2 is now called variance. Variance is a measure of variation.
how
Variance
5 years came?
Measure of variation.
Okay, n-1.
Yes. Now you take the square root. Now you take the square root of 1.2, which is 1.09. The square root of variance is now called standard deviation. Again, we are going back to this number only, isn't it? We squared it. Now we are taking square root. But now it is 1.09 is telling us a clear picture of the risk involved. Hope everybody is clear with the calculation of standard deviation. This formula, all of you have studied in your schooling. 7th standard. I have only recalled it. And now in this program, we are also going to make you use this very frequently in your business decision. Now, similarly for root B, will you now understand everything here? Yes.
Yes.
Similarly for root C. Now summary of the information is now available, presented to the team leader. Now you are the team leader. Tell me which route will you choose for your team?
1.09. A route.
2 reasons why you have chosen route A. One is the average depth is 4 feet.
Less.
Average depth is 4 feet. Another reason why you have chosen the route A is
It's minimal deviation.
Standard deviation is lesser compared to another.
exactly. If at all you have to cross the river compulsorily, the best route out of the 3 is route A. How do I know A is the best route? Standard deviation is less. When standard deviation is less, average can give you a better clarity of what is happening in the ground. Average can speak better when standard deviation is less. When standard deviation is less, your decisions will come with a better confidence. Am I right? The decision you make come with a better confidence. So standard deviation is the error. Error will pull down your confidence. You control the error so that your confidence will improve. Hope it is clear. This is the formula all of you have studied in 7th standard. Sigma equal to square root of summation of x minus x bar the whole square by n-1. This is the normal distribution all of you have studied in 11th standard. Probability and distribution. You had a separate chapter. Am I correct? In your mathematics book, you can see probability and distribution. And this, we have already mastered this. Now, one of you, can you read this particular statement? One of you, please read this statement. Up to this.
Yes, sir.
Yes.
99.70% of the area above points under the curve will be inside 3 sigma limits
That's all.
It means extremes under control limits.
Always, if your data follows normal distribution, 99.73% of the data will lie inside 3 sigma limit, which are called the control limit, which are called the extremities, which are called the worst outputs. Right? Now, one more statement. If the control limit overlap with the specification limit, condition added is control limit overlap with the specification limit. All of you, are you very clear with the control limit and specification limit?
Yes, sir.
Control limit is given by your process. Specification limit is given by your customer. Now, Bhavin, you read the statement.
99.73% of the parts produced will be accepted by the customer if control limits overlaps standard limits.
Specification limit.
Specification
Don't change the terms. Specification limits.
Specification limit.
All of you agree with the statement? If control limit overlap the specification limit, you are sure 99.73% of your production, 99.73% of your service will satisfy the customer. Please understand, in order to make the statement, you only require data. You don't have to produce everything. Please understand, you don't have to produce everything. You do a pilot production. Collect data over a period. It can be 1 month, it can be 1 week, it can be 3 hours production, a pilot production. But make sure your data is sufficient enough to visualize the normality. That's all. The pilot production tells you 99.73% of the parts will be accepted by the customer. Now the mass production of 1,000 units happen. How many units will be accepted? 997 will be accepted. 3 units will have the risk of getting rejected. When did I make the statement? Even before producing the 1,000 units. This is how statistics improves your predictability in the decision. You can better predict. Do you understand? Your predictions will be perfectly all right, provided your data is clean and credible, provided your sample size is sufficient, provided your sampling technique is appropriate. So that is the reason why you must master 3 areas. One is make your data clean and credible. Don't believe the liars. Always focus on the fact. Collect the data free from error. Go for an appropriate sample size. With a fewer sample, if you take a decision, you may end up making a wrong decision. Isn't it? Always go for sufficient number of sample. But here, the subject is big. So, sufficient number of sample. Which is sufficient? Depends on the scenario. I cannot say 30 is the sufficient. No. You have to figure out for your case. Sufficient number of sample size and appropriate sampling technique. If you are a king in these 3, you will be king in all scenarios. You will definitely dominate, any crowd, and you will be the winner always in terms of decision making. So this, see, now after calculating the average and standard deviation, we are able to talk about the entire river, isn't it? The river along route A has infinite number of points. Though the points are infinite, I am still able to comment on it. Same way, if you conduct the study in an appropriate manner, you will be able to answer this question. What is this question? How many dolphins are there? How will you answer this question? Will you go and meet each and every dolphin one by one? Impossible. You have to rely on some prediction. You have to rely on some statistics. Study a small portion over a small period of time, but design it very, correctly. Then you will be able to figure out the answer. This is how, our department, the government has the data. Because whatever is the problem for us, it is a problem for the government also. But they have did some study and they have answer for all these things. Now, what proportion of products will be accepted? Will you now be able to tackle these kind of questions? If somebody asks you, what kind of products you produce will be accepted? Will you be able to answer this?
Yes, 99.73.
That percentage depends on, where is your
Number of
control
samples.
limit.
Number of samples.
99.73 is true only if control limit overlap specification limit. If control limit goes beyond, 99 will come down. There will be more rejections. What proportion of the customers are likely to buy my product? I will get this question answered. So I can take better decisions, which is very, very essential for my business. Average is a measure of, what is your option here?
Central.
Central tendency,
Standard deviation is a measure of,
consistency.
it can be both. If the standard deviation is less, you are more consistent. If your standard deviation is more, you are inconsistent. So standard deviation helps you to understand both. Consistency, inconsistency, both can be understood. So I should add one more option, both. What proportion of data point will lie inside control limit?
99.7.
73.
Standard deviation is always a positive value.
No.
False.
False.
Standard deviation can be positive or negative. That is why we standardize it.
Yeah. Square root. Yeah.
It's a
true.
positive value. True. Normal distribution is symmetrical about center.
True.
Total area under the normal distribution curve is 100%.
No, false.
True.
Why it is false? Total area is 100%. I have shown you, isn't it?
One. Yeah, one.
Yeah.
You have to carefully listen.
Be 100% always.
Total area, how much?
100.
100%. Total is always 100%, right? For you, whatever you earn is that your total money. So similarly, total area is 100%.
Here, standard deviation is always in a positive. How it will be, sir?
Yes.
They're
Oh,
squaring it,
Only to make it positive, we square the values and then we take the square root.
Okay,
And then-
so usually the standard deviation values will be less than 1 or more than 1. Less than
No,
1.
no,
it will
not
be-
usually. It depends on data. It can be
Okay.
less than 1, it can be more than 1, it can be assume
Okay.
any value.
So if the more than 1 means, how we need to consider that? That is the deviation is high.
1 is not the reference, first of all. 1 is not the reference. It can have any value. If your
Okay.
data is having a more variation, then your standard deviation can be 20 also, can be 40 also.
Okay. So what is the normal range of the value for standard deviation?
See,
So
there
it will
is
be how we will work
there
on
is
that.
no rule that standard deviation should be within this.
Okay.
If I take bigger number, standard deviation will be bigger. Isn't it? If I take smaller number, standard deviation will be smaller. So there is no
Sir, can I
logic.
come?
Yes, sir.
You can take it as 3%, right?
Yes.
We put it in not in terms of what you have asked for. I'm giving an indirect answer that normally we say that 3% error. Like for example, in your house, no electricity comes. What is the frequency? 60 cycles, but nothing will be exactly 60. So plus or minus 1.5, right? Like
All
that.
right.
3% is the margin of error. Similarly, confidence level is 95%.
Okay.
Okay.
All right. If control limits stay inside the specification limit, the process is considered capable or not capable.
Capable, sir.
Specification limits are provided by
Customer.
Customer.
control limits are calculated using
Process data.
Process data.
Process data.
beautiful. Now comes the question, what is exactly Six Sigma? Six Sigma is a methodology to reduce the defects by reducing variation. Reducing variation means controlling standard deviation. Controlling standard deviation means working in the field. If you don't work in the field, standard deviation will not get controlled. If you are a professional who want to control the standard deviation, then you should be a real professional. You should work in the field. You should actually improvise the process. Then only standard deviation will get controlled. Am I correct or not?
Yes.
Yes, sir.
Only when you shoot correctly, your bullets can hit the target. Standard deviation can be 0. If you are hitting, here and there, if you calculate the standard deviation will be bigger only, right? So Six Sigma is improving your performance by controlling the variation. We talk at the CTQ level. We taught you CTQ. CTQ is critical to quality.
Quality.
If it is thickness, I am only talking about thickness. Even if the thickness is okay, still customer can reject my product. Do you understand?
Yes.
Thickness is okay. Surface finish is bad. Customer will reject my product. Thickness is okay. Surface finish is okay. But length is not appropriate. Customer will reject my product. We calculate sigma level for each and every specification. If a product has got 3 specifications, then all 3 specifications, if your sigma level is 6 sigma, then only at the product level your capability is 6 sigma. Do you understand my statement? Your product has got 3 specifications: thickness, length, surface finish. In all the 3, variation is less. Then only your product will be accepted. Then only majority of your product will be accepted. So you might be working on DMAC or DMAT B. That is depending on whether you are looking for an improvement from the current level, or you are developing something new. Developing something new is called DFSS. You go for DMAT B. Now let us take an example of a car hiring service, car hiring service. Companies like Ola, Uber, and Call Taxi and other things, they provide cars. How do you book the cars? You open their application, you book a car, and then car arrives in your place. Now tell me, for a company like Ola or Uber, what is the CTQ for them? What is CTQ for them?
Response time.
Car should arrive on time. Right? Car should arrive on time. If the mobile application says car will arrive in 30 minutes, car should actually arrive within 30 minutes. That will lead to success of the business. If the app says 30 minutes, but the car doesn't arrive even after 30 minutes, do you think the person will again open the app and book the car? No. Right?
No.
The CTQ is the time, the car arrival time. What is the maximum limit? If the app says 30 minutes, maximum limit is 30 minutes. What is the upper spec now? 30 minutes. Am I right? Because the application in a particular pin code, every time a person opens the app and search for a car booking, in that pin code arrangements are made to ensure car arrives within 30 minutes. That is the process. That is the capability of the company. So the app, depending on the capability, the app is showing you will get a car in 30 minutes. That means upper spec is 30 minutes. In this case, though the specification is decided by the app, that is considered as upper spec. Am I right? Because your customer has accepted it. Am I right or not? Now, what is the lower spec? What is the lower spec?
10 minutes.
10 minutes. And this is assumed by us. Theoretically, lower spec is 0. But when I say lower spec is 0, then in front of every house, I should have a car. That is impossible, right? So I have a fair assumption, which is 10 minutes. If 30 minutes is upper spec, 10 minutes is lower spec, what is the targeted arrival time?
20.
The center. What is the center?
20.
20 minutes.
So you designed a process in a way that everyone books the car using your application. Car will arrive in 20 minutes. That is the plan. Do you understand? That is the plan. It will arrive in 20 minutes or plus or minus 10 minutes, so that every single customer is satisfied. So this is now, if you are able to do it consistently, your process is considered capable. Now the information is visualized. Can you see upper spec? Can you see lower spec? Can you also see target? Now the specification width is 20 minutes. Can you see that? All of you. Upper spec minus lower spec gives you the width of the specification. How much is the width of the specification?
20.
20. I think everybody understands. Now, you want to understand, are you really honoring the commitment? What is the commitment? Car will arrive in 30 minutes. are we able to honor the commitment or not? Because you are the head of the division in that particular area. You are responsible for it. So you study the car arrival time. You collected the car arrival time. Nowadays, these are all automated and captured using the mobile app. So data is definitely available. With the data available, collected over a period of time, you are plotting a histogram. What are you plotting? A histogram. Histogram is another QC tool. All your cars over that period you studied has arrived between 10 minutes and 30 minutes. Can you see that? 10 minutes on the left, 30 minutes on the right. And between from 10 to, let us say, 10 to 12, 12 to 14, 14 to 16, 16 to 18, 18 to 20, 20 to 22, 22 to 24, 24 to 26, 26 to 28, 28 to 30. Something like that, no? It happens, 10 to 30. And for every small band, how many car arrivals happen? And now that decides the height of the bar. Now, out of the observations you studied, your bars are appearing like this. Your bars are appearing like this. Let me explain one thing. This one. Let us say out of 100 cars, 20 cars have arrived between 24 minutes and 26 minutes. This is 24, this is 26. 20 times your cars have arrived at the customer place between 24 minutes and 26 minutes. All of you understand the meaning of the bar?
Yes.
20 is the height of the bar. Here it is 10. Here it is 5. Now you will be able to see a bell curve. If you connect the points, approximately it is following a bell curve. Now, with your collected data, you calculate the average. With the collected data, if you calculate the average, it is now called process average. Process average is different, target is different. Target is 20. Process average is X bar. Process average is X bar. You are able to see process average also equaling 20. What is the scenario now? Process average is on the target. Now tell me, how are you holding your gun? Are you holding it correctly? Yes or no?
Yes.
Yes.
The number of cars attached, the number of the way you trained your drivers, the GPRS system you have provided, and the mobile application you have designed, you have developed. Everything is perfect enough. What is required is only performance. What is required is the correct performance without deviation. If everybody follows the instruction, every single customer will be happy with your service. How do I come to know? From the average. Average on the target is a very, very healthy scenario. But when the performance actually happens, there are variation. That is what you are seeing in the form of bars on the right side, in the form of bars on the left side. But with the variation, you are calculating sigma. What is sigma? Standard deviation. You are calculating standard deviation. How much is the standard deviation here?
3.3.
3.33.
3.33. My interest is to see the control limit. What is the formula for control limit? Center plus
2 sigma.
3 sigma.
3 sigma.
So 3 into 3.33, 10. Center is 20. 20 plus 10, 30.
30.
Similarly, 20 minus 10, 10. Your lower control limit is 10, upper control limit is 30. Now I want to understand what is happening in the field. My process width is 20. My specification width also 20. I want to understand my capability. So I overlap both the width, specification width overlapped with process width. When I overlap the specification width with the process width, I found they are exactly equal. Now comment about the capability. What is your capability? Is your process capable or not capable?
Capable.
Just capable. You just made it, isn't it? You just made it. Your success rate now is 99.73. Am I correct?
Yes.
If 1000 bookings happens, 997 times, your car will arrive within 30 minutes. But 2 or 3 cars might arrive late. That is your capability. All of you understand?
Yes.
Yes, sir.
This process is statistically called a 3 sigma process. This process is statistically called a 3 sigma process. You know why? There is 3 sigma variation on the right side. There is also a 3 sigma variation on the left side. And so the process is called 3 sigma process. When I say variation, it is the distance between the process center and the nearest specification. How many sigmas are there between the process center and the nearest spec?
3.
So the process is called a 3 sigma process. All of you now understand what is a 3 sigma process?
Yes.
You see 3 sigma variation on the right side as well as on the left side. What is the success rate? 99.73.
1.73.
Right. This process, I'm going to give a nickname. The nickname is elephant process. Because you need to realize you have parked a big car in an area exactly similar to the size of the car. Do you remember our discussion? The first slide. Car size and parking area exactly same.
Yes.
If your girlfriend makes a call, what will happen?
Damage.
Your car is going to damage, right? So you will, the moment you lift the car, no call, your car is hitting the wall. Similar situation you have created. Control limit is touching the specification limit. Am I right or not?
Yes.
So you need to realize your process is now wider. In order to tell you your process is wider, I am naming this process as an elephant. It is very wider animal, isn't it? You have now locked a wider animal in a room similar to the size of the animal. Do you think the elephant will stay calm inside the room?
No.
You are sleeping on the next room. You are sleeping on the next room, and this room you have put the elephant. The size of the elephant and size of the room is same. But in the midnight, 12 o'clock, the elephant will come to your room. Am I correct or not?
Yes.
So if you wanted to avoid the situation, give some additional space for the elephant. It will at least walk whenever it is tired, it will walk and then take some rest and do something in its room. Same allowance is required for your process also. Agreeable or not?
Yes.
Yes.
Sir, agree.
So that you are not able to provide the allowance because your sigma is bigger here. Sigma is 3.33. That is the reason why you are not able to provide the allowance. All right. Now this process assures, in spite of all these problems, this process assures a success rate of 99.73. Can you see the rejections in red color?
Yes.
0.27%. Half of it on the right side, half of it on the left side. I am not marking rejections on the left side because it is car rental service. Rejection will happen only on the right side. Car doesn't arrive in 30 minutes, customer will cancel the order. If the car arrives before 10 minutes, customer will not cancel the order. Am I right? So no failure on the left side, but there is failure on the right side. So the rejection is visualized only here. But suppose if the elephant comes to your room, why the elephant has come to your room?
Rejections.
Uncontrollable factors have played. Your girlfriend has made a call. Your raw material quality is deviated. Your machines have undergone wear and tear. The operators have took leave. These are uncontrollable factors. Sometimes what you do is you make mistake on controllable factor also. You set the machine wrongly. If you do all those things, the elephant will definitely come to your room at the midnight. You can't sleep. Am I right or not? This is called process shifting. If you allow the elephant to, if you make the elephant to come to your room, this is statistically called shifting the process. Process will generally shift by a distance equal to 1.5 sigma. By a distance equal to 1.5 sigma. This is a statistical estimate. Since the process has moved, the control limit will also move. Am I right? And now look at the rejection. Rejection was 0.27, but now how much it is? 0.27 is true when your elephant is in the proper area. But when the elephant comes to your room, 0.27 becomes very big. Your profit is 8%, but rejection is 10%. Can you tolerate? Definitely no. That is why process improvement. That is why process control is important. Process control means ensuring the elephant stays always here. This is called SPC, Statistical Process Control. You are making sure elephant always stays in its room allotted. That is SPC, Statistical Process Control. Right? If the elephant goes here, you will again bring it here. This is called SPC. If you don't even allow the elephant to enter your room, if you restrict the elephant to enter your room, that's called process improvement. That's called process improvement. We'll see that, right? So now this is the rejection rate and everything we have understood. What is this process called? 3 sigma. A 3 sigma process, which was very good at some point of time, has become very bad now. Am I right?
Yes,
The 99.73 has now become less than 90% because rejections have gone above 10%. So 3 sigma process is okay only considering the short-term benefit, only considering the short-term result. But considering a long-term result, even a 3 sigma process is not capable. Am I correct with my statement?
yes.
Yes,
So
sir.
process improvement is required. So you realized as a professional, as a 6 sigma professional, you realized an improvement is required. You attached more cars. You even trained your drivers on how to behave, how to talk, even certain communication in English. You have trained your drivers. You have taken care of the maintenance of the car. Some quality checks you introduced. You have upgraded your mobile application. You have improvised your GPRS system. There is a dedicated call center provided to communicate between customer and the driver. With all these things, do you think the performance of your car arrival improve? Yes or no?
Yes.
All the points I suggested are field work. Nothing to do with the statistics now. Attaching more cars, conducting a training for the drivers, taking care of the maintenance of the car, and providing some additional quality check on a weekly basis, upgrading your mobile application, adding
Increasing the commission.
Yes, sir.
Increasing the commission to the drivers.
Yeah, increasing the commission to the driver. This has nothing to do with the statistics. This requires your domain knowledge now. Whatever you have studied so far comes into picture now only. You are an engineer. Use that now, not the statistics. Now I have helped you to draw a clear line when the engineering knowledge is required, when statistical knowledge is required. Which is required first? Your domain knowledge or the statistical knowledge?
Domain knowledge.
Domain knowledge comes at the time of offering the solution. But before offering the solution, you have to define the problem. You have to measure the problem. You have to analyze the problem. For all these things, statistical tools are required. What we do is most of the time we directly jump to the solution by using our domain knowledge. Don't do that. Particularly when the problem is complex. Particularly when the issue is critical. Don't do that. Don't jump. Rather, go face by face, define, measure, analyze, improve, and control. For sure, you will be able to deliver result. That is what you have done here. That is the reason why your efforts are reflecting positively in the sigma. Can you see the sigma now? How much it is?
1.66.
1.66. The sigma is 1.66. Now look at your control limit. Control limit is now just 25, not 30. Look at your lower control limit, just 15, not 10. Right? Which means you have converted the elephant into a giraffe now. Your elephant is no more wider, it has become thin, like the giraffe. Your normal distribution curve will start appearing narrower. Now, specification width is 20, but your process width is only half of it. Specification width is 20, but process width is just half of it. You are giving your child a pocket money of 20 rupees, but your child wisely spent only 10 rupees. The child is saving, 10 rupee in the savings. Do you think the saving will help in the future?
Yes.
Definitely. Customer has given you so much tolerance, but your process is using only half of it. Now your process is doubly capable. Your process is doubly capable. Now tell me, what is the distance between the process center and the nearest specification? How much is the distance? Look at the slide and tell me. Come on, quick. How much distance you are seeing between center and upper spec?
6 sigma.
In terms of sigma, it is 6 sigma. In terms of unit, it is 10 units. Am I right? 20 here, 30 here. 10 units. See, 10 is nothing but specification value minus process center. USL minus X bar divided by your sigma. Sigma is how much? 1.66. 10 divided by 1.66. How much? 6. That is what you are appearing in the form of sigma. 6 times 1.66 is 10. So it is, the distance is 6 sigma on the right side. Similarly, 6 sigma on the left side. The process is statistically called 6 sigma process. Process is statistically called 6 sigma process. It can give a result better than 99.73. If the elephant or the giraffe try to come to your room, the process is called giraffe. Why I give the giraffe name? Because it is appearing narrower. And moreover, the curve will become taller in the center. And so the nickname is giraffe. Even if the giraffe tends to come to your room, it can move only by a distance of 1.5 sigma. Can you see here? It has moved by 1.5 sigma. As a result, control limit will also move by 1.5 sigma. Everything will move by 1.5 sigma. Now the percentage of unit beyond control limit is indicated in red color. Am I correct? Out of the red color area, only a small portion is going beyond specification. This small portion is 3.4 dpmo. This small portion is 3.4 dpmo. What is dpmo? Defects per million.
Per million of outputs.
This process, even after the shifting, can still remain capable. And now the success rate is 99.999%. Success rate is 99.999%. Earlier, we calculated success rate 99.73, assuming the sigma level is 3. But now we calculate success rate of 99.999, assuming a sigma level of 6. I also incorporated the process shifting. Please note, when I shift the process, how much distance it will move? 1.5. Subtract the 1.5 from 6. What is the remaining number now?
4.5.
4.5. When this 4.5 is actually called G score, which you will be learning in the analyze phase, is actually called G score. When G score is 4.5, success rate is 99.999. Please note, the 99.999 is not a short-term success. It is a long-term success. It can even tolerate the process shifting. All of you understand?
Yes.
So what is this process? Is it elephant or giraffe?
Elephant.
Elephant.
What is the sigma level?
3.
Look at the G score. G score is how much? 3.
3.
What is the success rate? 99.7. Tell me, is this success rate is short-term success or long-term success?
Short term.
Only short-term. Very good. Good understanding. Now, what is this process? Is it still remaining elephant?
Giraffe.
It has become giraffe. So statistically, what is the sigma level?
6 sigma.
6 sigma.
6 sigma.
6 sigma.
That is the reason why control limit is, going inside. And now what is the success rate now?
99.999.
99.999. This 99.999 is arrived using a jet score of 4.5, not 6 sigma, not 6. That means we are accommodating shift of 1.5, isn't it? Shift of 1.5 is accommodated. Something can go wrong. Still your girlfriend can call. Still the equipment can undergo wear and tear. All those problems can happen. So in spite of all those things, we are assuring a success rate of 99.999. Now, considering the car rental service, the process is one-tailed or two-tailed? One-tailed. Failure happens only on the right side. Am I right?
Yes.
Left side failure is not a failure. So your success will be little more than 99.999.
Sir, here I have doubt.
Yes.
For lower specification limit, so it will not affect one tail means. So even though if you are in a more than on time means that will impact our business, right?
No, that we will deal it. That is an efficiency issue. Please understand.
Yes.
That is an efficiency issue. That is why Lean has got a tool called just in time.
Okay.
When the car is required, that time only car will come to you. Till then it will serve some other client. That is, now we are talking about effectiveness.
Okay.
Once effectiveness is ensured, we will think about efficiency. Effectiveness is first very, very important. Am I right?
Yes.
There is a gaining a knowledge in the training program is very important. Getting
We
the
will
certificate
discuss-
is also important.
Yes. Overproducing we will need to discuss later.
Which one will you give priority? Getting the certificate or gaining the knowledge?
Knowledge of-
Gaining the knowledge.
So same way, there are two things, effectiveness and efficiency. Effectiveness gets prioritized. Then comes efficiency, right? We'll talk about
Okay.
it in the lean subject. Today evening you have a lean session. So
Okay.
99.99966%, that means corresponding failure is 3.4 DPMO, where DPMO stands for defects per 1 million opportunities. If there are 1 million bookings happening, 3.4 times or 3 or 4 times car might arrive beyond the
15 minutes.
upper spec, beyond the expected time. But if the process is two-tailed, your success rate will be slightly lower. For example, a manufacturing scenario where we reject the product if it is over dimension, we also reject the product if it is under dimension. Now the success rate will be slightly lower for a Six Sigma process, two-tailed 99.99932%. The corresponding DPMO will be 6.8. Hope everybody now understood the milestone, the meaning of milestone 3.4 DPMO. Am I correct?
Yes, sir. Sir, I have one more doubt here.
Yes.
Sir, could you please go to the previous slide? Thank you, sir. So here, if you are 3 sigma means we are running the process with specification limit. If 6 sigma means we are running the process with specification as well as the control limit. Is my understanding correct, sir?
See, always, for customer, it is only specification limit. Customer will
Yes.
not talk about control limit.
Yes.
But we will talk about control limit. Inside the company, we will talk about control limit.
Yes.
If you ensure control limit is well inside the spec, your capability will improve.
Yes.
If you think you can take the control limit close to specification limit, then, it is like, walking on the knife. Anytime your leg might get cut into pieces, isn't it?
Yes.
If your control limit is touching the spec, okay, today everything is going fine. But something wrong, really big, can happen tomorrow or next month. So to avoid that, it is always a good idea to keep the control limit well inside the spec.
Yes. In
Right?
a 3 sigma slide, we see that only the specification limit. So in that we are not discussed about control limit.
No,
But
no,
when
no,
it
no,
comes
no,
to
no. You
this-
have not noticed. You have not noticed. Even if I see here, can you see UCL here?
Yes.
Can you see LCL here?
Okay.
I told, control limit will overlap with the specification limit.
Okay. Okay. Got it, sir. Thank you.
So if the variation is too high, which is not good for your company, that is what is, the slide is talking. Variation is too high. Your process is like an elephant in a small room. Your variation is too less. Your process is like a giraffe in a very spacious room. You are given a 4 BHK now. You have a lot of space to move around. You will definitely be happy and you will stay inside the room, isn't it, for a longer time. Same way, your process will also stay there and give you a performance, a long-term performance. Your capability is high now, your rejections are low now, because your sigma level is in the order of 4.5 to 6, which means virtually everything you produce will please your customer, will meet the customer requirement. This is called the Six Sigma way of problem solving. Hope everybody understood. How we used the numbers. The game of business is converted into a game of numbers. The game of business is converted into a game of numbers, which is statistics. We will be able to play the game very well if we are strong in normal distribution, otherwise definitely not. Please spend some time, quality time, read some literature to further understand the normal distribution. Then only you can continue in the program. All our future lessons will depend on your understanding on the normal distribution. Otherwise, you are not going to become a Six Sigma professional. There are many places where statistics is not given importance. You are now in a platform where we give equal importance to the theory as well as real life. So spend some quality time and look at the normal distribution table and come up with some doubts. We are there to help you. There are dedicated slots provided on Wednesday and Thursday, 1 hour each. Make use of them. You will see yourself as one of the best Six Sigma expert in the market. You will definitely be on the top 5% of the black belts, of the green belts in today's market, right? So Six Sigma method delivers results every time, provided it is executed properly. Other methods deliver results rarely, and you can make a choice. Benefits, revenue will go up, there will be a top line growth. Profit will also move up, there will be a bottom line growth. You will enjoy both. Cost will go down. Cost of poor quality will definitely go down. Your resource utilization, efficiency will improve. You can see people working smartly, isn't it? And all those things. And most importantly, this culture of adopting Six Sigma will make each and every employee in the organization a super effective professional. A super effective professional eventually will turn out to be a leader. A leader will spread the culture and make everyone super effective. And this is what you can notice happening in companies using Six Sigma as a way of management. At the hiring level itself, they will talk about Six Sigma, right? And definitely those companies are premium companies and everything will be better there. So Sigma level is a measure of process capability. Specification limits are the limits provided by the customer. Control limits are the limits calculated using process data. A 3 Sigma process can assure a result of 99.73, which is only short term. However, a Six Sigma process can assure a result of 99.999, which is a long-term success rate. In a 3 Sigma process, control limit will overlap with the specification limit. In a Six Sigma process, control limit will stay well inside the specification. The customer tolerance, only half of the customer tolerance will be consumed by your process. That is why we call it doubly capable. Higher the Sigma level, higher will be the capability. Sigma level is different, Sigma is different. Sigma is a measure of risk. Sigma is a measure of variation. So if you allow the Sigma to increase, that will pull down your Sigma level. If the Sigma increases, capability will decrease. That's it from me. If there are any questions, you can ask. Any questions? Are you good now? Do you got the question answered? What is exactly Six Sigma?
Yes, sir.
All right. These slides.
Defects per million opportunities differ from DPU and DPO, sir.
Yeah, that will be taught today afternoon. Please wait for it. Defects per million opportunity is different from defects per unit, defects per opportunity, but they are connected. From defects per opportunity, only we calculate defects per, only from defects per unit, we calculate defects per opportunity. Only from defects per opportunity, we calculate defects per million opportunity. Please bring a 5 rupees gems chocolate today afternoon.
You ask me a question, 10 questions you are asking me. What is a defects per opportunity? What is a defects opportunity?